number one, if you're using that method number one, or did you try to use method number two? So like, did you, for problem 5, specified value of x, for what we referred to as method 2. So, did you use the implicit?
Yeah.
Okay. Just making sure. It happens. So your original would be x equals y cubed plus 2y minus 1. So then you would take the derivative of that. And then you would factor out your 3y squared and 2, and you get dy dx equals 1 over 3y squared plus 2. So it asked you to find the inverse derivative at x equals 2. So that x equals 2 is really like the original x value. So if you're finding the derivative of the inverse, the x value of the original becomes the y value of the inverse. So what that means is that dy dx is actually being evaluated at y equals 2. So our answer is 1/14. And you could compare that by finding the y value of the original when x is 2. So 2 cubed is 8, plus 2 times 2, which is 4, is 12, minus 1, which is 11. So what that would mean is that the original point is 211. So what we were finding was its inverse, which is 11/2. So this is really like saying f inverse prime of, and in this case it would be 11, because you always find the inverse prime of the derivative at its x value, which would be the equivalent of our other formula of saying 1 over f prime of 2, which is exactly what this represents, because that's really the derivative of the inverse, but with respect to variable y instead of x. So this is like our method 1. Like what I did in pink is our method 1. What I did in red is method 2. But I was kind of trying to hope to show you the connection between the two. And of course I picked two colors that are really similar. Like I should not have picked pink and red. Does that help everybody? Like you in here and you, Nick?
That makes sense to me. Yeah, thank you.
You're very welcome.
My mistake was that I was thinking the x equals 2 was in respect to the inverse.
Okay. And that is a very, very common mistake. Like you're not alone.